Hey guys, welcome back. We're right now to a day that I'm going to go ahead and warn you. This is where the chapter kind of takes a little bit of a turn and becomes a little bit more complicated. But stick with me. We're going to take it one step at a time. I'm going to give you guys plenty of chances to practice today, and it's going to be all right. But I just wanted you to know ahead of time, this is going to be it's going to be a tougher day. But we still got this. So what is today going to focus on? Well, looks like we're dealing with, hey, this isn't too unfamiliar, compound inequalities. And, I don't know what this is. Actually, I do, I'm the teacher. That's a lie. Interval notation. So that's going to be the part that probably is a little bit confusing for us. But let's kind of focus firstly on what we do know and what we do recognize. So let's start with compound inequalities. Well, we know how to solve multi-step inequalities. That's what we spent these first 3 days kind of working on. But look at our second standard here. The first part doesn't look too unfamiliar, graphing a compound inequality. But then, oh snap, interval notation again. So that's going to be the key that we kind of spend the second half of today on. But what I want to give you guys a chance to do is we're going to work a couple of these compound inequalities together. I'm going to pause the video. I'm going to throw up a couple questions for you guys to practice. And really, let's really focus in, guys, on these first 5 problems, because if these still confuse us after today, we may have a tough time with these last 2 days of our chapter. So what are we doing? We're going to write a compound inequality to represent the solution set, and then we're going to graph it. So quick reminder, what are our 2 kinds of compound inequalities? Okay. Hopefully you said and or. And we know with and problems, that's whenever our variable could be 2 things, right? It could be greater than this number and smaller than that number. And with or, we know we're dealing with, well, our variable, it could represent a number that is this or that, but it can't be both. And a quick reminder, we know that with and graphs, where does the shading go as compared to or graphs? How's the shading going to look on these guys? Take a second, see what you think. All right, let's take a look. So and problems, we know the shading goes together. Or problems, the shading goes apart. So that's one way you can tell whether you're dealing with an and or an or problem. Another way you can tell is going to be in these problems, we got to look for the word. So all real numbers, I'm going to go with a variable everybody uses. Let's call that Q. Everybody uses Q. That's the most popular variable. That are greater than -2, and oh shoot, check it out. What word do you see right there? It's going to give it away. We got ands. So we know that all the numbers are going to be greater than -2 and less than 6. So immediately in your head, you should be thinking, okay, I know I have an and problem. That means our variable is going to be trapped between 2 numbers. So let's put those 2 numbers down here. We've got -2 and we've got 6. And we know Q is going to be in between those. Or if it's less than 6, let's start the left to right way that we know is a little bit easier to write these inequalities. So less than 6, Q's less than 6. And remember, with an and problem, the arrows go the exact same way. So you can cheat a little bit here. And we know Q is going to be less than 6, and Q is going to be greater than -2. Next one, all real numbers that are less than 0, and then there it is, or are greater than or equal to 5. So think about what variable do you want to use. Let's go with my 6th favorite variable, R. So we've got R is going to be less than 0 or greater than or equal to 5. And we know that if those variables, or if those graphs are going to be split apart, then R is going to be greater than 0, and then bust out the actual word itself, or, oh, I'm a big dummy. I'm a big old dummy. R is going to be less than 0, my bad. Or R is going to be greater than or equal to 5. Sorry about that. Yep. R is going to be less than 0, or R is going to be greater than or equal to 5. Now, there's no number that exists that is both those things. So when we go to graph this, quick reminder, got our point at 0, got our point at 5. Now, which one of these points is going to be an open circle? Which one's going to be a closed circle? Did you say 5? Let's go. Why is 0 not going to be a closed point? Well, because R is less than 0. It's actually not equal to it. So when we go to shade, we know that R is going to be less than 0, so we go to the left. Less is left. R is going to be greater than or equal to 5. It can't be both, though. So it's one or the other. As opposed to an AND problem, which real quick, both open circles up here, because Q is greater than -2, Q is less than 6, shading is in the middle. So right now, I'm going to pause the video, and I'm going to give you guys a chance to try 3, 4, and 5 for me. Let's see what you guys can do here. Remember, watch for the word and, watch for the word or. And if you catch those, these problems are always going to look very, very similar. So give it your best shot, guys. Okay, let's see how you guys did. So 2 ways to write this first one. You could put z is greater than or equal to -4 and then put 6 over here on the left. We know z is less than that. Or you could have done z is less than 6. And then z is also, of course, greater than or equal to -4. They're both right. I went with C, my favorite letter. All real numbers that are less than or equal to 2/2, or C is greater than 6. And then I went with T for my last variable. No reason in particular. We know all real numbers that are between -7 and 1. So T is going to be greater than -7, and T is going to be less than 1. Hopefully you guys did great on that. So here's where we're going to kind of get into some of the complicated stuff. We're really going to have to take our time here. We're actually going to be solving some of these. So take a second. Remember what we know about solving. Usually you want to get the variable by itself. The problem is these first couple are going to involve the word and. These are the weird ones where your variable is kind of stuck between two different sides here. But these actually aren't too bad to solve. Like, for example, look at number 1. So our variable's in the middle of this thing, isn't it? We've got a left side, a middle, and a right. If the variable's in the middle, we want to get everything but the variable out of the middle. So if m is being subtracted by 4, we're going to add 4. And you're probably thinking, wait a minute, where do we add 4 to? Well, not only do you add it to the middle, but we got to keep this thing balanced. You add it to the left and to the right. And so that gets rid of that in the middle. We know m is going to be greater than or equal to -3 plus 4 is 1. And -1 plus 4 is 3. So hey, m is going to be less than 3, but it's going to be greater than or equal to 1. So we bust out our graph. We got 1 here. We got 3 here. We know 1 is going to be a filled-in point because m is greater than or equal to 1. We shade to the right. M is going to be less than 3, open circle. So we stay in the middle. So before we look at that scary number 2, let's do an OR problem together. Let's get a quick reminder here on OR problems. So check it out. And I'm sorry that this writing's in the way. I don't know why that printed on the bottom of this page, but that's all right. So what I love about OR problems is they're just normal inequality problems. It just so happens there's 2 of them. So check out number 1 here. You see how this is split kind of down the middle? We've got this problem or this problem. So let's solve them separately. So this first one, we subtract 2 over, bada boom. We get 3t is less than, now remember -7 and -2, we're subtracting, so that makes it bigger negative. You divide by a +3, so okay, no negative. So we're not going to have to flip our sign. Hallelujah. So t is going to be less than -3. But we can't stop early here. Don't forget over here, we got to solve this one. Subtract 5 over. -4t is less than 1 minus 5 is -4. And then, oh shoot, you got to divide by -4. And when you divide by a negative or multiply, you have to flip the inequality sign. So t is now greater than -4 divided by -4 is +1. And don't forget OR, because we're dealing with an OR problem. When we go to shade, we've got -3 on the left, 1 on the right, both open circles. And we know if it's an OR problem, we're shading away from each other. The shading is not connected. It's got to be one or the other. Can't be both. And so before we try this really scary number 2 problem, before we try that, I want you guys to try Try solving and graphing number 2 here. Try solving this word problem for me. We already know what the graph's going to look like. I want to give you guys a chance to see how you're feeling on these word problems. Remember, we solve them just like equations. You just have to watch out for if we divide by a negative number. So go ahead, guys. All right, let's see how you guys did. So again, it's an OR problem. So we split it up into 2 parts, and we solved the first part, dividing by, subtracting 8, dividing by 5, x is less than negative 6, or subtract 2, divide by negative, oh wait, we divided by negative 6. Oh shoot, we got to flip that inequality around. X is greater than negative 3. And now, if it's an OR problem, we know that if we're less than negative 6, we're shading left. Greater than negative 3, we're shading right. We got an OR problem there. And so guys, here's where something called interval notation is going to come back into play. Interval notation. So this is a way we can describe how the solutions look. So we have them written kind of in answer form here. M is greater than or equal to 1, M is less than 3. We have them written in graph form. And really, interval notation is just how we represent the graph. It is a representation of our graph. And here's kind of the weird part about interval notation. Stick with me, guys. Stick with me. We use parentheses or brackets, sometimes both. And we use these to set limits. This is a way to limit our answer and show where exactly the numbers are that our variable could be. It could be 2, it could be 2.5, it could be 1.5. And so here's a little secret. We always start on the left side, so interval notation. How far does our shading go to the left? So our shading goes, looks like to 1. We put a comma, and that comma is us traveling to the right, traveling to the right, traveling to the right, and it looks like we make it over to 3. Now you're probably thinking, wait a minute, where does the parentheses and brackets come into play? Well, if you have an open circle, you will use a parenthesis with that number. Open circle, you use a parenthesis with that number. If you have a closed circle, you will use a bracket with that number. Notice I said a bracket. Like for example, look at number 1 here. Shading to the left at 1, 1's a filled in point. That's a bracket. Then we go over to 3. Oh, that's an open point. That's a parentheses. Oh, that's not too terribly bad. So bracket 1 over to 3. This represents and limits kind of our answers here. It shows us where our solutions are. Let's try it for one of these word problems. Now here's where this gets a little complicated. Here's where this gets a little complicated. So interval notation for number 1, I'll put it over here. I like to use IN to abbreviate our interval notation. You're going to want to give yourself a little bit of room here. So it looks like, how far to the left does our shading go? Well, it kind of keeps going left, doesn't it? Yeah, that thing's going to keep going left. In fact, it's going to go left forever. And is it going to go left in the positive direction or in the negative direction? Which way are our numbers if you go to the left? Ooh, in the negative direction. So we go negative infinity. That is a terrible infinity sign. Comma. How far do we end up going? Looks like to, boom, negative 3. So from negative infinity to negative 3. Now here's the thing. It looks like that's an open circle, so we put a parenthesis. And here's the thing. With infinity, you can never reach infinity. So that will always be a parenthesis. Just like negative 3, we will never reach negative 3. The shading stops just before negative 3. Ooh, but wait a minute. Doesn't our shading pick back up over here? Oh, man, that's right, it does. Our shading picks up over here, and it looks like we're going from 1, comma, And we're going right forever. So we're going right forever. That would be infinity. Once again, we got parenthesis around infinity. That's an open circle at 1. We got a parenthesis. And with an OR problem, we have to connect these two shadings. We have to connect them with our interval notation, and we do that by using a union. We use what's called a U, which is a union that ties together. We'll put a U that ties together our two sets of shading here. So that's interval notation for an OR problem. I know it's a little bit complicated. Try number 2 for me, please. See if you can do the interval notation. You should have a little bit more room for this one. See if you can do number 2's interval notation. All right, so we're going left forever to negative infinity. Remember, infinities, we can't reach them. That's always a parenthesis. Looks like we make it over to negative 6 with an open circle. So we got parenthesis. Then we bust out the U, Miami University. And that U jumps us from negative 6 over to negative 3. Open circle, so that's a parenthesis. And then we're going to infinity. So here's where all of our answers are. Our answers are all between negative infinity to negative 6 and from negative 3 to infinity. Very, very good, guys. And let's wrap up. Last thing today. Let's wrap up at the top. Of page 14. Now you are going to have a few homework problems, just giving you a little heads up here. So be ready. There are going to be 6 problems here. We're not going to touch those word problems. We're not going to do these. So real quick, before we look at a couple examples, what would happen, guys, if we had x is greater than 2? Let's make this up. X is greater than 2. I want you to graph this for me. Go ahead and graph it. So we know we've got 2, 3, 1, open circle. X is greater than 2, so we're shading to the right. Now, what would be the interval notation of something simple like this? We just have a little graph here, no and, no or. This is just a basic inequality. Well, how far to the left does our shading go? How far to the left? Looks like it gets right around 2. Parentheses, right? Open circle. Comma. How far to the right is our shading going? Where are our answers at? Looks like we're going, oh shoot, we're going forever to the right, aren't we? That's some good old infinity action right there. Close parentheses. So we've got from 2 to infinity. Yeah, these basic inequalities they're pretty easy to do the interval notation for. Okay. Now, I'm going to give you guys a chance to try 1, 2, and 3. By the way, the shading is right here for this one, if you can't tell. The shading is right here and here for this one, if you can't tell. And then the shading's almost everywhere for this one. So I want you guys to try these 3 for me. And let's see what you end up with. We're going to be writing the interval notations for these. So, interval notations. Okay. So for number 1, we have an and problem. Shading runs together. From the left, we are at negative 2. All the way to the right, we are at 3. Open circles, because negative 2 and 3 are not part of our solution. Bada boom. Number 2, we're going from negative infinity all the way to negative 1. Now, how do we bridge this gap? How do we jump the gap? We use a U. Bust out the union that connects this shading to this shading and says, hey, this is all one thing. So we union that over to bracket 1. Why are we busting out the brackets here? Because these are filled in points. They're part of our solution. And we're going to infinity. We're heading on to the right forever. Now, last one. Number 3. This one looks kind of scary. Wait a minute. Is there a little gap in the middle where we're not shading? Yeah, that's where that point is. So if the shading's not connected, it's not an and problem. So it's not. So this was an or. This was an and. Let's see what this one's going to look like. So here's our interval notation. How far to the left is our shading going? Oh, it's going to keep going, isn't it? Negative infinity. Now, where does it stop at? Looks like it makes it 2, close to 2, not quite at 2, right, because that's an open point. But that's why we use parentheses to show that it gets right up to it but never hits it. And then wait a minute, there's a space in the middle where we jump, so we use a union. And where do we jump to? Well, the other side of 2. Okay, so now we're on the other side of 2, and where are we heading? Looks like to the right forever. So wait, what kind of problem is number 3, guys? Is it an and or an or problem? Yeah, there's space in the middle. The shading's not connected. This is an or problem. So there you go. We've done a regular inequality. We've done a compound and inequality and some compound or inequalities. And so I'm sorry for the way number 4 printed, guys. But I'm going to let you guys try number 4, which starts right there for some reason. I'm going to let you guys try numbers 5 and 6 for homework. So go ahead, guys, give these your best shot. And I'll be talking to you guys soon.